Hello Group 1 aspirants, welcome to TSAT, the second session of this space technology. In the last session, we have learned about natural satellites, artificial satellites, and we also talked about defining the orbit, and we also talked about various types of orbits like a geostationary orbit, geosynchronous orbit, and then we also talked about orbits based on the altitude, that is LEO, MEO and HEO, that is low Earth orbit, medium Earth orbit and high Earth orbit. And also we were talking about transfer orbits and geostationary orbit. Now let's move on to another one, that is why do we have different stages of satellites. So as a reaction of this, a thrust acts on the vehicle. So we all know that we have all, in all the classes we have learned, every time when we talk about the rocket, we will talk about something, and then it is something like this. If a gas comes out of this rocket with some velocity v, then this rocket will also move with a velocity v also. And this v is actually the reaction. And this is the one which we have given because of this burning this fuel, and the gas will actually comes out of this with a particular velocity, that is v velocity. And then if this object also moves in the opposite direction with the same velocity. So this is what drives the satellite. So as a reaction of this, the thrust act on this vehicle, which actually drives the vehicle high into the space. Since this is not sufficient power, we could not generate the sufficient power, especially with our existing launch vehicles. So we have used this technology called transfer orbits. So why do we have two stages, a three-stage launch vehicles? As we were talking about the velocity that is required to escape the orbit, to escape the influence of the Earth, we need to have 11.3 kilometers per second. But what we are talking about, we are talking about a 7.8 kilometers per second. So this is the highest that we could reach with our existing launch vehicles. So it is very difficult to reach this. So that's the reason why what we are doing is we are actually having a multi-stage launch vehicles. So if you observe the structure of the launch vehicle, so which is decided by the weight of the satellite and the type of the satellite orbit. So if we want to send a satellite to a low Earth orbit, that is just above this Earth, that is 162,000 kilometers, the fuel of the vehicle also depends on these three factors. If you want to send into the low Earth orbit, if you want to send into the high Earth orbits, the fuel would be different. So you need to have more fuel if you want to send a satellite to the high Earth orbits, especially geostationary orbits. Geostationary orbits are above 35,000 kilometers. So if you want to send a satellite to the above 35,000 kilometers, we need to have more fuel. So how can you take this more fuel? So if you want to take more fuel, you need to have more chambers for this. So if you keep on having taking this in a single chamber, that chamber cannot be carried out till 35,000 kilometers. So that's the reason why what they use the technique of this different stage of launch vehicles. So in this, what they do is the fuel that forms a major portion of this total weight of this launch vehicle, thus the vehicle has to carry a large weight of the fuel with it. Since it has to carry a huge amount of the fuel, so it is very difficult. To overcome this problem, what they do is the launch vehicles with more than one stage are used. Which means, suppose if you want to take, let us take 100 tons of fuel. What they do is this 100 tons of fuel can be divided into three stages, that is 30, 30, 40, something like that, or depending on, it's not the exact number that I'm trying to give you, and I'm trying to make a sense of this, so that I'm giving this number 30, 30, 40. So in this, what happens, when this first 30 tons of this fuel is consumed, the portion that is attached to this 30 ton fuel would be sent back. So in this, what they do is, in order to reduce the weight of this vehicle after its launch, what we will do is, the portion that will actually will separate itself from the launcher itself. So once it is separated, then we will actually have this 30 and another 60. So like that, we will actually reducing the weight of the launch vehicle by actually removing the portion of that launch vehicle that actually exhausted the fuel. So for example, consider a launch vehicle having 2 stages. For launching this vehicle, the fuel and the engine in the first stage are used. So what they do is, this imparts a specific velocity to the vehicle, takes it to a certain height. So this imparts a specific velocity to the vehicle and takes it to a specific height. Once the fuel in this first stage is exhausted, the empty fuel tank and the engine are detached from the main body of the vehicle and fall either into a sea or on an unpopulated land. So thereby it actually reduces the weight of the entire launch vehicle. As the fuel in the first stage is exhausted, the fuel in the second stage is ignited. So that means we have already completed stage 1, and now we have moved into the stage 2 in this 2-stage launch vehicle. So India has 2 operational launch vehicles. So India has 2 operational launch vehicles. So these operational launches are called Polar Satellite Launch Vehicle and Geosynchronous Satellite Launch Vehicles. So we will call this as a PSLV and GSLV respectively. The GSLV with indigenous cryogenic upper stage has enabled the launching up to 2-ton class of communication satellites. So what is this cryogenic upper stage? Cryogenic is nothing but is a type of engine that uses actually the hydrogen and nitrogen. So the cryogenic engine uses liquid hydrogen as the fuel. So this liquid hydrogen is a very efficient, and it would actually produce more power. That's the reason why we are using this cryogenic part in geosynchronous satellite launch vehicle, because we want to keep our satellite in geosynchronous orbits. We need more power to that, because that height, that is altitude, is around more than 35,000 kilometers. So here, that's the reason why we are using this cryogenic engine. So it is an upper stage engine. We will talk about this in detail now. The next variant of the GSLV is a GSLV Mk3 with the indigenous high thrust cryogenic engine and a stage having capability of launching 4-ton class of communication satellites. If we want to use a bigger satellites, obviously the satellite's weight would increase. If we want to use a smaller satellite, the smaller satellite will have less weight, higher satellites will have more weight. If we want to take a satellite, a bigger satellite, obviously we need a more height, more weight. So more weight means we need a powerful launchers. So powerful launchers mean we need a powerful engines. So powerful engine is, what is the powerful engine that we could use? That is the cryogenic engine is the most powerful engine. So that is the reason why we will use this powerful engine, cryogenic engine, in these GSLV satellites, whereas in polar satellites we are not using this cryogenic engine. So Vikram Sarabhai Space Center located in Thiruvananthapuram is responsible for the design and development of launch vehicles. So this, for designing and development of this launch vehicle, this PSLV and GSLV is designed in Vikram Sarabhai Space Center, Thiruvananthapuram. You can see here this place. The Liquid Propulsion System Center and ISRO Propulsion Complex located at Valiamala and Mahendragiri respectively. So in Valiamala we have a Liquid Propulsion System Center, and in Mahendragiri we have ISRO Propulsion Complex. So these two develop the liquid and cryogenic stages for these launch vehicles. So for the launch vehicles, the fuel comes from these two places, that is Valiamala and Mahendragiri respectively. So in Valiamala we have liquid propulsion fuels, in Mahendragiri we have propulsion complex systems, therefore a cryogenic stage. And we have one more important thing is that is Satish Dhawan Space Center, that is SHAR. It is the space port of India and is responsible for integration of these launches. So it is on the east coast of India. It is on the east coast means it is somewhere here. So what I would like to say is why we are having these space centers like SHAR is on the east coast of this India. So we all know that the earth revolves in its own axis from west to east. So this is west and this is east. So earth moves from west to east, right? So if we want to launch a vehicle, so we should actually launch this vehicle in this direction itself. So if we want to launch in this direction itself, it should actually go in this way itself. It should go in this way itself. If you send this satellite like this, then what happens? We need more power because the earth is moving in this direction and you want to move in this direction. So you need to have double the power that requires. Instead of that, it is always good if the satellite also goes in this direction itself. So that is fine. So whatever the earth, in the earth's direction itself, we have to move in the same flow itself. So this is number one reason. Number two reason is, in the event of any untoward situation, in the event of anything that happens to this, what happens to the satellite? The satellites will fall down. It has to fall down on the earth. So if we send this satellite from this to in this direction, if anything happens, it actually falls on the populated area. We were talking about the stages. There we were talking about that whatever that completed exhausted fuel tanks would actually detach from the launch vehicles. Those detached parts will actually fall down. If a satellite move in this direction and then it fall, that whatever the detached parts falls, then it would fall on the earth itself. So this is not what we are expecting. We want these parts to be should fall on the ocean itself. So in order to do that, what we always have satellite launch vehicles on the east coast itself. That's the reason why most of this, especially these European countries, don't have these space centers. They actually depends on some other areas like French Guiana and all, because the entire Europe does not have this east coast. So that's the reason why they actually depend on other countries. And India is tapping that. We have sent satellites of other countries also. So that is where we were, we have a geographical advantage. So what we have talked about, the Satish Dhawan Space Center, that is Shore, is on the east coast of India. So we have also talked about why this satellite center is on the east coast itself, because of these two reasons. So it houses this two operational launch pads from where these all GSLV and PSLV flights takes place. So be it GSLV or PSLV, these both flights takes place from this shore itself, that is Sriharikota. So now let's talk about the satellite launch vehicles. That we use two types of satellite launch vehicles, that is Polar Satellite Launch Vehicle and GSLV, that is Geosynchronous Launch Vehicles. So now let's learn more about the Polar Satellite Launch Vehicles. Polar Satellite Launch Vehicle is the third generation launch vehicle of India. So before that there are two more launch vehicles were there, but this is the third generation. That's the reason why we're calling it as a third generation. So it is the first Indian launch vehicle to be equipped with a liquid stages. Liquid stages means the satellite is having a liquid fuel in that engine. That is the reason why we are calling this liquid stage. After its first successful launch in October 1994, PSLV emerged as the most reliable and versatile workhorse launch vehicle of India, with 39 consecutively successful missions by June 2017. So during this 1994-2007 period, the vehicle has launched 48 Indian satellites and 200 satellites for customers from abroad. So besides, the vehicle successfully launched two spacecrafts, that is a Chandrayaan-1 in 2008 and Mars Orbiter spacecraft in 2013. So that latter traveled to the moon and another Mars respectively. So Chandrayaan-1 actually traveled to the moon, and the Mars orbital spacecraft, that is Mars. So that's the reason why we call this as Mars orbital spacecraft. So this spacecraft has 4 stages. There's a stage 1, stage 2, you can see here. This is stage 1, this is stage 2, this is stage 3, this is stage 4. And this is where actually the satellite is kept. So in this first stage, when we actually launch this, the fuel that is there in this first stage is consumed. Once the fuel is consumed and this part is detached from the launch vehicle. Once this stage 1 is completed, this is detached and the stage 2 fuel actually comes into picture. And the stage 2, what happens? Once the stage 2 fuel is exhausted, this will also get detached. So when these two get detached, the remaining part is this mass itself. Here in the third stage, the fuel starts burning in this third stage. Once this is also exhausted, and we will actually fourth stage will comes into picture, and this third stage will actually gets detached again. So like that, in every stage the weight of this satellite will actually decreases. As the weight decreases, it is easy to achieve a high speed and it is easy to achieve more power. So that is the reason why we have 4 stages in this. So this is a final stage. In this final stage, again, once this is completed, it will get detached to the satellite itself, and the satellite is in this part. Now let us talk about a geosynchronous satellite launch vehicle. Geosynchronous satellite launch vehicle Mark II is the largest launch vehicle developed by India, which is currently in operation. This fourth generation launch vehicle is the 3-stage vehicle with 4 liquid strap-ons. So liquid strap-ons, or these are the liquid strap-ons. The indigenously developed cryogenic upper stage, which is the flight proven, forms the 3rd stage of GSLV Mark III. That means it is somewhere here. So this is the stage 1, this is stage 2, this is 3rd stage. So these are the things that we have in this satellite, that is geosynchronous satellite. So geosynchronous satellite is having 3 stage, whereas PSLV is having 4 stage. So from January 2014, the vehicle has achieved 4 consecutive successes. A payload fairing is a nose cone, that is this part, at a diameter of 3.4 meters. The payload fairing of the GSLV is wider than the rest of the launchers. So since it is a wider than that, it is easy to take a much high weight to the different spacecraft, different orbits. The fairing provides aerodynamic efficiency and shields the payload from the mechanical damage during the atmospheric phase of flight. What happens, I would just like to give you a small glimpse of this. When a satellite launcher moves at a speed of 7.8 kilometers per second, you can imagine how fast it is moving. If it moves with this speed, you know, even a small dust particle would also act like a bullet on this satellite launch vehicle. So we have to design this satellite launch vehicle in such a way that it would not damage this satellite launch vehicle. Since it moves so fast at this speed, it actually generates the heat also. So it generates the heat means it would sometimes reach 3000 to 4000 Celsius centigrade. So we have to, this satellite should have the shield also. So in order to, you know, safeguard this entire payloads from this mechanical damage, we will be using this fairing part with this. So far we have learned about what is artificial satellite, what is natural satellites. We have also talked about the definition of the satellites. We have defined the satellite's orbit, and then we'll also talked about the various types of orbits based on the function. That is, we have learned that the types of orbits based on the function are geostationary, geosynchronous, polar satellites, and sun-synchronous satellites. And we'll also learn about the types of orbits based on the altitude. That is, we have learned about LEO, that is low Earth orbits. Low Earth orbits are orbits which are in between 160 kilometers to 1000 kilometers. And we have learned about the high Earth orbits. High Earth orbits are orbits with more than 35,000 kilometers, and they are called high Earth orbits. And the medium Earth orbits are in between these LEO and HEO, and they are called MEO. And then we'll also talked about launch vehicles. India, why do we have different stages of launch vehicles? That is, we have 4 stages launch vehicle, we have 3-stage launch vehicles. We've actually learned about that, and after that we have learned about the different 𝗧. We have learned about why every 𝗧 kind of 𝗧𝗦𝗔𝗃 is on the east coast, and we also learned about the polar satellites. We'll also learn about polar satellite launch vehicle, and we also learned about the stages of this polar satellite launch vehicle, and we have learned about what we have learned in this what kind of satellite we have launched using this polar satellite launch vehicles. Major like Chandrayaan-1 and Mars Moon mission, both are accomplished by using this polar satellite launch vehicle. And we have learned about a geosynchronous satellite launch vehicle, and in this we have learned about the different stages, and we have also talked about the cryogenic engine and why do we use this cryogenic engine. So these are the things that we have learned. Thank you.